entire system is described by h of s is equal to 1 by s square plus 3s plus 1. The system response for the input x of t is equal to 2 into e power minus t. Find the DC gain at the output of the above system. So we have to find the DC gain of the system. Okay, now what is y of s? Y of s is equal to h of s into input x of s. So this one is equal to x of s is 2 by s plus 1, okay, into h of s, this is s square plus 3s plus 1. Okay, now limit s tends to 0, y of s is equal to nothing but DC gain. DC gain means omega equal to 0. Substitute omega equal to 0 here. Okay, when omega equal to 0, y of DC gain is equal to 2 by 1 into 1. So this is DC gain value at the output system is 2. So that is option A is the correct answer. Now he has given x of t is equal to cos of t plus 20. Now we have to find what is the output of the above system. Okay, we have to find output of the above system when the input is x of t is equal to cos t plus 20. Okay, now calculate this one. See here, he has given input as x of t is equal to cos t plus 20, where omega equal to 1, phase phi is equal to 20 degrees. Okay, now what is h of j omega? H of j omega is equal to, I can write this one as 1 minus omega square plus j times of 3 omega. Okay, now what is h of j omega at omega equal to 1? Okay, this is equal to 1 by 0 plus j times of 3. So magnitude of this one is equal to, at omega equal to 1, is equal to 1 by 3. What about phase? Phase is equal to minus 90 degrees. Now what is output y of t? Y of t should be multiplied with magnitudes. Okay, y of t is equal to, what is the magnitude of x of t? Only 1. Y of t magnitude is 1 by 3. So this is 1 by 3 into 1 cos of, okay, t plus 20, phase is minus 90 degrees. So this is equal to 1 by 3 cos t minus 70 degrees. Option C is the correct answer.
Here, the circuit is given in the figure. We have to decide what kind of function it's going to perform, whether it is going to perform decoder or encoding or multiplexing or demultiplexing. See here, if A1, depending upon the A1 and A0, D3 or D2 or D1 or D0 are going to be passed. Only one of those are going to be passed. Means it is acts as a selection lines. So it is a multiplexer. So option C is correct. Comes to value of f, if A1 both are equals to 1 means C3 is going to be 1. So D3 is going to be passed to the F. So option C is correct.
Three-phase equilateral transmission line has a corona loss of 53 kilowatt at 106 kilovolts and a loss of 98 kilowatt at 111 kilovolts. What is the critical disruptive voltage? Now see here, corona loss, let us take PC, is directly proportional to V phase minus V critical disruptive voltage whole square. Okay, now he has given this is a three-phase transmission line, so total corona loss per phase is 53 by 3, okay, divided by, okay, per phase we have to calculate. This is at phase voltage, line voltage of 106 kilovolts. So what is the phase voltage here? 106 by root 3 minus VD whole square. Similarly, we have 98 by 3. This is at a line voltage of 111 kilovolts. So this is 111 by root 3 minus Vd whole square. Okay. Now only one variable we have and equation. So critical disruptive voltage Vd, from this you can find it as 53.4 kilovolts. So option A is the correct answer. Now what is the enhancement in corona loss at 113 kilovolts when compared to 111 kilovolts? Now what is the corona loss at 113 kilovolts? We have to find first. Okay, divided by corona loss at 111 kilovolts per phase is 98 by 3. This is equal to 113 by root 3 minus critical disruptive voltage is 53.4 whole square divided by, okay, and this is 113 by root 3 and 111 by root 3 minus 53.4 whole square. When you find this one, corona loss at 113 kilovolts is equal to, it will be nearly 40 kilowatt. Okay, in question he doesn't ask anything about corona loss at 113 kilovolts. Okay, he asked about what is the enhancement. Okay, now corona loss at 111 kilovolts is 98. Okay, whereas corona loss at 130 kilovolts, okay, this is only per phase we got it. So 3 into 40 is 120 kilovolts. This is for 3 phase, whereas this is for single phase. Okay, corona loss at 111 kilovolts is 98, whereas 113 is 120 kilowatt. So what is the enhancement here? 120 minus 98, which is equal to 22 kilowatt, is the answer. Option A is correct answer.